So today we're going to talk about functions and their domains, which we actually have talked about in the past, but we're going to look at it a little differently today. So first thing we need to do is define a function, which is something that people often forget the definition for. Often it's pretty easy to remember what the definition is if you see a graph. So like a parabola is a function because for every, or if it passes the vertical line test, right? Which the reason that happens is because a function is defined as a relation where every input, and when we say input, we're talking about the x value, maps to one and only one output, which typically we talk about as the y value. Okay, so if we look at a circle is not a function because when I draw that vertical line test and that vertical line represents one input, we get two outputs or two y values on that line. Okay, so with that said, before I define domain, I actually want to look at a series of equations, and I want us to just look at these for a second. In fact, if I were you and you're watching this video, I'd pause it before I give you the answer to see if you can figure out which one of these gut feeling would not be a function. Now remember, before you pause it, and if you already paused it, oh well, a function means that every time I put an x value in, I will only get one y value out. I only want one. So take a second. So if I look at these, one of them that's a clear indication that it's not a function is this one right here. That plus or minus means there's going to be two y values automatically. Okay, that means this is not a function. Okay, and then there's one more on this list that actually has a huge red flag, and that's this one. Because it's y squared, this tells us once again there will be two y values because the y itself is squared. So notice I didn't care about the x squared. That means we're going to get two x values. That square right there tells us we're going to end up with two y values. And here's another reason why. So by the way, it's not a function. So if I subtracted 13x, I'd get 7 minus y squared equals 7 minus 13x. And then if you solve for y, and you take the square root, you need to remember that you always end up with a positive and negative answer. Okay. So I don't have to solve it. That was just to show you. Big indication that something's not a function is if your y value is squared or it's raised to some other even power. So it always has to be an even power. Okay. So as just kind of a heads up, a function is not a function if you see a plus or minus, and it has to be grouped like that. So like this equation over here has a positive and a negative in it. It's still a function, okay? Or you see y squared, okay? That, if you're going to write anything down, is something I would write down. So let's go back to domain. So domain is the set of inputs. And remember, an input means x values. So it's all the x's that produce real number outputs. So y values. Okay, so just in case you're wondering what would not be a real number. So not real numbers, if in case you're wondering. Something that's not a real number are imaginary numbers. So if they have an imaginary or complex. Complex means it has a real and imaginary part, although that's confusing. So let's just say imaginary numbers. Because because the only reason a complex number would be considered not real is if there is an imaginary part. Okay, so I'm just going to say imaginary numbers. And the second non-real number is an undefined number. And the most commonly used undefined number that we know of at this point is when you divide by 0. Okay. Imaginary numbers are when you have a square root of a negative number. Okay. So that's what we're really looking out for. Or like those are the things we don't want, I should say. Otherwise, all the numbers will be good. So let's go ahead and start talking about how to find the domain of a function. And once again, we're going to determine, are these actually functions or are they not? Okay, so this first one, this is a function. I'm going to go ahead and say yes, function. And that's because there's no plus or minus. Oops. No plus or minus or y squared. Okay, so that's the reasoning that you can automatically look at that and go, oh, we know this is not a function, or we know this is actually a function. Then the second thing I need to do is figure out if there's what the x values I'm allowed to plug in. Meaning, can I ever get this equation to give me an imaginary number, or can I ever get it to be undefined? Here's how you'll know if you can get either one of those. Imaginary numbers are only possible if you have a square root or any other even root. Getting something that's undefined is only possible if you're dividing by 0. So those are the two things I'm looking for when I'm trying to determine what the domain of a function is. This first equation, y equals x squared minus 3x plus 1, has neither a square root or division in it, which means I can literally put any number I want in for x as long as it's a real number. I can put any real number in for x and get a y value that is also likewise real. So for that reason, you just write this is all real numbers and we're good to go. That's the all real numbers symbol. So if we look at the second example, number 2, once again, we got to determine, is it actually a function? Once again, we would say yes, it's a function because there's no plus or minus or y squared, right? You don't have to put the reasoning behind it. In fact, on this one, the reason it's all real numbers is because there's no square root or division. Now, this second one, we have a square root. So what we're doing is we've got to make sure that we don't get negative numbers. Now, negative numbers, the barrier between negative numbers and positive numbers is 0. So when it comes to square root problems, we just want the inside to be greater than or equal to 0. So that's what I'm doing right here. I want this to be greater than or equal to 0. So for my domain, I'm going to say x minus 3 has to be greater than or equal to 0. I solve and I find out that x has to be greater than or equal to 3. Now notice I solved it just like a normal equation. I just added 3 to both sides. That's how you deal with inequalities. Okay, let's see another one. Another several. Okay, so example 3 over here is not a function. We've already talked about y earlier, and the reason being because there's that plus or minus. So let's go to example 4 then. Example 4 is a function. And the reason, just in case you want to remind yourself, is there's no plus or minus or a y squared in our equation, so we know it's a function. So that takes us to domain. Okay, this is the hardest part. So remember, the two things for domain we're looking out for are square roots or division. Okay. Now, there's no square root on this one, okay? So I don't have to worry about the whole greater than or equal to 0. But we do have division, and we don't want to be dividing by 0. So what you're doing is you're just, if you remember last unit, we're essentially finding the vertical asymptote. We're just stating what the vertical asymptote is, and we're just saying it can't equal that. So in this case, we'd say x plus 2 can't equal 0, so x can't equal negative 2. because if you subtract 2 from both sides, you get negative 2. That is it. That's your domain. I should be writing that. That is the domain. Notice when it's not a function, I don't find the domain. It's only when it is a function. Okay, let's do a few more, like I said. Okay, so this problem, the first one, is a function. And once again, it's because there's, oh, bless me, sorry, no plus or minus or y squared in it. And then for domain, just as a reminder, you're looking for square roots, or for division, we do have a square root. When you see a square root, you always just make it greater than or equal to 0. And I'm only going to take the interior, the inside of that square root, and set it greater than or equal to 0. So one way we can solve this is subtract 5 from both sides, because we're treating that like an equal sign. And then divide by negative 1. Now, warning, when you divide or multiply by a negative number and there is an inequality, you have to also switch the direction of that inequality. Okay, so that's pretty important. Those switch because you divided by a negative number. Oops, probably should use pen. That would help. So your answer is x is less than or equal to 5. Some people on this kind of problem will just add x to both sides and then it just automatically gives you the answer. Okay, this next one is not a function, and once again that's because of the y squared. All right, let's do a few more. Sweet. For this first one on this page, it is a function. And once again, the reason being there is no positive or negative symbol, the plus or minus symbol in this, or a y squared in the equation anywhere. Then we're looking for domain. Remember, you look for square roots or division, and if there are none, you just say your answer is all real numbers. It's like the easiest type. So once again, that's no square root or division. Okay, let's do our last one of these types, I think. Or maybe I lied. Oh, I lied. I'm such a liar. So this one's also a function. Once again, for the same reason. I'm just going to go ahead and write for both of those. Now, domain, we actually have both. So this has both a square root and division. Okay, so you're going to have to, when you're dividing by a square root, you just add one, or you take away one part of it. Because a square root, we want it to be greater than or equal to 0. While division, you don't want it equal to 0. So when you combine them, you would just, so if we're dividing by a square root, you would say that the inside just can't be, or just has to be greater than 0. So we just make it so it's not equal to 0. Take the little equal to symbol off. So for this problem, I'd just say x plus 1 is greater than 0. I'll subtract 1 from both sides, or I'll find the 0, and x is greater than negative 1. So when it's both, it's not equal to. So both division and square root. Okay. Like I said, I lied to you, so let's do a few more. All right, so these last two are both functions. There's no plus or minus symbol. There is no y squared, so both of them are functions. So that just leaves us to our last part. So Remember, for domain, you're always looking for square root or division. And this last one has neither, so it's all real numbers. This one is a division problem. So I'm going to go ahead and just find the zeros. So the 0 of x plus 2 is negative 2. So I'd say x can't be negative 2. If you don't know the 0 of 2x minus 3, just set it equal to 0 and solve. So you add 3 and divide by 2. So you'd also say x cannot equal 3/2.